page 212, 9.4. This is random sampling methods. Why is it important to have a random sample? Think of any of the things we talked about for statistics, data, anything that we talked about that's important.
What was the
Stocks. That was the big one we were talking about yesterday, right? So anything. Sorry, what? Crying baby. I don't think I want to get back into the crying babies thing. But stocks. If you're trying to figure out all these different stocks on average, unless you want all the individual data points from every single day from everything, which sometimes you have computers that can do that. But if you're looking for something over a longer period of time and you're just trying to do a sample, if you don't have digital access to it, or you're trying to, maybe it's gather information about people, like who is interested in this stock, who is interested in this stock, you're going to want a random sample of the people who are there, unless you're planning on spending a bajillion hours getting all the different information on everything, right? So it's really important that you when you actually take samples of data, that is a completely random sample. All right, page 212. Sample size, you guys already know what sample size, that's just the portion that you take out of whatever the whole is. So samples need to be random, they also need to be non-biased. What does it mean to be if a sample is biased? So let's talk about, I don't know, you're sampling people to see if they're interested in, or what they're interested in for what?
Video games.
Video games, okay. So if you're trying to just figure out, in general, the general public, and you're trying to do an unbiased sample of what video games they're interested in.
You do it random.
How do you do that? So what would, if you did, let's just say, okay, I want to survey 10 random people. I pick 10 people in this room who play video games. Is that biased or unbiased?
Unbiased.
What?
Unbiased.
Nope.
If you say I'm going to pick 10 random people, it's not being biased.
Why is it biased? Yeah?
Everybody
No,
plays
you.
video games,
Yeah,
so.
Emma.
Because we're all kind of in the same age group, in the same class.
Boom! You're in the same age group, you're in the same classroom. That is a totally biased sample. You guys know each other. You probably influence even what video games each other play.
But if you're trying to figure out how many people play video games in this class,
That wasn't what I said. I specifically, because I had that in my mind, I specifically said, of the general public. If you're trying to get a good idea of what video games people play in the general public, then I would do that. If I was figuring it out in this classroom, honestly, I wouldn't even do a sample at that point. I would literally just ask everybody in the classroom, what's your favorite video game, or what video games do you spend the majority of your time playing, or whatever. I don't think I would need a sample size for that, because it would be not that much longer to get not that much more information to gather everyone. But if I'm trying to get things in general, or just in Watertown, or if I'm trying to get specifically middle schoolers in Watertown, I would have to go from every school in Watertown, right?
Mm-hmm.
Because every middle schooler is in their own classroom. You're going to have at least some influence, because you play with probably at least one or two other people in your classroom. Maybe not everyone, but the majority of people are going to play with a lot of people that they go to school with as well. So you want that sample to include, it can't be biased. So whatever you're looking for, you got to make sure it's not going to be biased towards one group or another. So there's three really big ways that we talk about doing this. There's simple random sampling, stratified random sampling, and systematic random sampling. So page 213 on the bottom, or midway through, understand simple random sampling. Number one, can I have, well, I think there's, 1, 2, and 3. Can I have you guys read those out loud? You guys can pick whatever one you want. 1, 2, or 3. 1? Okay. Use a sampling frame. Go.
In carrying out a household survey using telephone interviews, you may use a telephone directory. You randomly flip to a page of the directory and randomly choose a telephone number. Repeat the process until you have gathered enough members for your sample.
Okay, so you just flip into a random page or whatever. Sounds simple enough. 2, lottery method. Yep.
To generate a random sample of students from the school population, you may assign a unique number to each student at the school. The randomly picked numbers from a box that holds all the numbers.
So it's a literal lottery where I'm just giving you guys all random numbers. I put them in here, and boom. I mean, it would be like for speeches today, right? For speeches, I said random sequence generator. That's the same thing for what order everyone's going to be in, because you guys were all assigned numbers. The random sequence generator doesn't know anything about that, and boom, it generated all the different numbers. That was basically the lottery method. Number 3, next page 214, using a random number table. Emma?
Suppose you want to pick a random sample of 30 people in a town that has only 500 residents. You first assign 3-digit numbers from 1 to 500 to the town residents. You may use a random number table like the one shown below to select members of the sample. To use the table, choose any row, then from left to right, read off 3-digit numbers. Use only numbers from 1 to 500 if the number is greater than 500. You discard the number and move on to the next 3-digit number until you have chosen the one. The numbers may match to the numbers of the array.
Alright, so with that, basically you just see it's got a random number table there for you, which is great if you want to take the time to do that. And 4 says using a computer instead of using a random number table. You may also use a random number generator on a calculator or computer to generate random numbers. Which of those 4 sounds like the most appealing that you're probably going to go with every single time? What? Which of those 4 is the
Random
easiest?
number table.
What?
Random number table.
No, it's not the random number table. Get out of here. You're having trouble getting that open? Lottery method? That's what you're gonna choose? What are you gonna choose? What? A computer? Okay. Emma and me are only ones on the same page. You guys can use the other ones if you want. I personally think, like, it's really, really fast to just use a computer with whatever it is. Yeah, I read that one out loud. I didn't see it
There's
first
only
either.
3. Oh, then there's 4. Okay, I
Yeah.
didn't see the 4th
So you
one.
can use one of those ones. However, that's like in general the one that you would want to use. The next 2 that we talk about, stratified and systematic random sampling, those are, I think it's better, it's more important to understand how those work than how the first one. Those first ones are really simple to talk about, yes? Yep, as long as it's facing me. The next one, so is stratified random sampling, page 216. So stratified, well, I never got to teach you guys about this in geology, but maybe you guys do remember a little bit of it. Yeah, geology, this is geology. So, which of the forms of rock, so there's the 3 main types of rock. You guys remember what the 3 main types of rock are? Sedimentary, igneous, metamorphic. So sedimentary, igneous, metamorphic. Which of the 3 is the one that had a lot of layers that are really pressed together?
Oh, sediment.
Nope. Metamorphic, yep. Metamorphic is the one. Another name for metamorphic rock, when you see things pressed together in those bands, is called strata. So it's like a stratified rock is a rock that is pushed together in sections like that. And stratified data, all this means is it's got lots of different bands of individual things in it. And so stratified data means that you're saying, hey, I'm going to take one from this, one from this, one from this, or taking certain things from different sections. I'll explain a little bit more. Let's read, so separating things into random schools by random sampling with stratified data. Number 1, page 216, can you read that? By schools.
Suppose you want to know the mean height of middle school students in a district with 3 middle schoolers. You first divide the students by their schools, then you randomly select students from each school. The number of students selected from each school is not necessarily the same. That didn't make sense.
Okay, I'll explain. So let's say you've got 3 schools. Let's even talk about in Watertown. Let's say this is the middle school. This one is, let's say it's Faith, because Faith is really, 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 really small. And let's say this is Good Shepherd. Maybe that's not exactly accurate. But if you're trying to find the average height of a middle schooler in Watertown, do you want to take just from the middle school because it's the biggest one? No, because that's somewhat biased of a sample. You want to try to take an even distribution.
You'll have more from the middle school than Faith.
That's the thing. You're going to have more from the middle school. So let's say you're going to take, I don't know, what percentage of each school do you want to take?
What, 10?
10%? Okay, so let's just say you take 10% of whatever it is, and you say, hey, Good Shepherd has, of students in middle school, let's define middle school as 6th through 8th grade, because that's generally what it's considered. Let's say that Good Shepherd has 30, let's say the middle school has, what do you guys think, like 300?
There's more than that.
More than that, 500?
Probably
1,000? Okay, we'll just say 500. I have no
Not
idea
even
actually.
high schools have that.
And let's say Faith has 10. Faith actually I think has less than 10 at this point, but doesn't really matter. So if you're trying to get an accurate thing, and let's say these are the only 3 schools in Watertown, you would say, hey, I'm gonna take 10%. I'm gonna take 3 random ones from Good Shepherd. I'm gonna take 50 random ones from the middle school, and I'm gonna take 1 random one from Faith. That should give me, that's called stratified data, because I can figure out, hey, I'm taking this from this, this from this, this from this. In general, it should be representative of the whole thing. Make sense? Okay. Number 2, by genders. Can you read that one?
Suppose you want to conduct a survey on whether people prefer to eat organic. To make sure that you have an equal number of men and women in the survey, you may want to divide people by genders. You then sample randomly 30 men and 30 women to interview.
Makes sense, right? You're gonna say, obviously sometimes that you have preferences when it comes to, by genders for different things as well. So you're gonna make sure you do equal men and equal women for some things. Number 3, by chapters. Emmy, you wanna read that one? Top page 217.
Suppose you want to find the mean word length of words in a book. You may randomly select a few words from each chapter, as shown in the table below. Then you calculate the mean word length of all the selected words.
Okay, so they're saying, hey, you randomly select a few words from each chapter. It doesn't even need to be the same in every single chapter. We got chapters 1, 2, 3, and 4. 4 and 5. We're on page 217. Yeah.
I get my Chromebook so I can get the numbers for the.
Sure. So you've got just random numbers from all of them, and then you look on average, what are they all going to look like, and that's going to give you a good idea on what the average word length in a book is. So that's stratified. Stratified means that you're separating it into
Layers.
or groups, yeah. So stratified, layers / groups. The last one is systematic. Systematic on page 217, understand systematic random sampling. So it says on the top there, to carry out systematic random sampling, you select the first member randomly, and then select subsequent members at regular intervals. So let's say that I'm trying to do the video game thing that I'm talking about, right? So let's say I have all of this, I'm trying to figure out what is representative for what video games you guys like of all of the middle school students. So this is specific to all the middle school students. I have all the middle school students line up alphabetically or whatever it is. It doesn't really matter how they're lined up. It could be completely random. And I say I'm going to choose the first student randomly give me a number like 1 through 10.
10.
2. Okay. So I'm going to choose the second one, and then afterwards, I figure out how many students are there total. So we said there was like 500, right? Let's say I want to sample 10%, those 50. So that means I have to do 500 divided by 50. That means 1 out of every 10 students. 1 out of every 10 students I'm gonna have to select. So I select the second student, the 12th student, the 22nd student, the 32nd student, and I keep on going over and over and over and over again until I hit that 50 mark. If that's what I'm trying to get, if I'm trying to get 50 of them. But you figure out, hey, here's the total. I'm dividing it by how many I want out of it, and that means I have to go every 10th student. Whoops, that was impressive. I want every 10th student there, so I choose a random number in the first 10. I didn't even realize that was in the first 10 on top of my head. Kind of got lucky there. And then I keep on going every 10th student after that. We'll look at a couple of examples though. You wanna read the first one, every 12th household?
There are 300 households in a district. Suppose you want to obtain a 25-member sample. Label all the households in some numeric sequence. Divide the number of households by the sample size. 300 over 25 equals 12.
Okay,
Pick,
so yeah, we got 300 total. We're dividing them in 25 groups because we want 25 total samples, and that means we're gonna do every 12th household. Keep going.
pick the first household at random among the first 12 households according to the numeric sequence. Then
Okay,
select.
so you can stop. So they said, hey, we're gonna choose the 5th one randomly at first, and then add 12 to that, 17, 29, so on and so forth, until you get all the way up to 300, and then you're done. You just randomly do ones like that. Every 8th minute, I'll just read through these other ones because they're faster. To conduct an opinion poll among tourists at a historical site, you intend to spend 4 hours at polling 30 tourists at random. 4 hours. So you know that you're spending 4 hours total, and it is 60 minutes for every hour, and you know you want to get 30 total, so 4 over 30, cancel those out. This is 1, 2, so that means you know every 8 minutes you want to poll someone, and you just say, hey, random number between 1 and 8, pick one.
3.
3, you go 3, 11, 19, so on and so forth. Is 3 the book, when the book actually said? Oh, I didn't actually give one. The last one would be every 200th item, canned food manufacturing site produces about 5,000 cans a day. Quality inspectors pick a random sample of 25 cans for examination. So I've got 5,000 divided into 25 different groups. That means I've got every 200th can, I have to pick one of them. This is something a quality control inspector would actually do. They would actually sit there and be like, hey, I'm not checking every single can, but I can check every 200th can if I'm trying to get 25 total things for my sample size, and randomly pick a number between 1 and 200.
47.
145. You said 147?
Huh?
You said 147?
Yeah.
Oh, that's very